systems and networking also. So we'll see these topics. So first one is about the servers and services. I made up this name servers and services because here we discuss about mainly different types of servers and what are their services. Okay. And then after this one, we will discuss about a domain controller server, okay, DHCP server, DNS server, okay, like that we will discuss. Okay, here it is. The first starting is peer-to-peer model. The peer-to-peer model is very general model. It's kind of work group model only. It means you have a you have a computers or a devices. You can say you have a computers or a devices connected in the network. Guys, this is representation of devices connected in the network. That's it. It does not mean there are connected in the bus topology. It's not like that. Okay. Of course, bus topology is look like this one only, but the point is when you say devices connected in the network, will show like this only. Okay. Devices are connected in the network. That is a symbolic representation. I have a device A and B and the C and the D, for example. Okay. So these are the devices, like my computer, your computer, other computer. These are the simple computers, devices, printers. Okay, like that. In these computers are connected in the network. What is the purpose of devices connected in the network? Is it to communicate between them? Different type of communications. It can be a printer, network printer it is. Okay. So we can send messages. Maybe you will share the data. I have a data in a PCA. I can access the data from PCB. It is also communication, right? Sending messages, sharing data, sharing resources. For example, here is a printer is connected to a device. It's not a network printer. So I am going with a simple organization, not much bigger. So simple. D is connected to a printer. So if you anybody want to access this printer, they can access through this DPC. So they'll send a request to the DPC for printing and the DPC through print will be occurs. Okay. So here it is sharing of data, sharing of information or sharing of resources can happen. That's why we connect devices in the network. Okay. So they will send a messages or maybe they will share the data or maybe they will share the resources like a printer. So this is smart network, but without centralization. There is no specific centralized control for user login purpose, resource access purpose, or some information access purpose. Through the centralization, it's not doing anything. Okay, there is no centralized control or no centralized server is not there here. Simply one-to-one communication only. That's why it is called a peer-to-peer. Peer-to-peer. It means it's a one-to-one communication. Okay. So it is in a simple in this particular one in a particular instance, a device is act like a server, other device is like a client. For example, I'm a client. I'm not a client. I'm also a system. That is also another computer. Just I want some information from other computer. So I like a client and that is like a server. But there is no specific server, no specific client here. But in that particular instance, only a device is act like a server, other device act like a client. For example, here in this diagram, D is connected to the printer. A want to take a printout from D, from the printer which is connected to D. A send a request to D, I want to take a print and D allow you to take a print. It means A act like a client, D is act like a server. But D is not a print server, A is not a print client. In that particular instance only, it is act like a server and client. Okay. It's a kind of workgroup model, sharing of information, data, resources between two or more systems without centralization or a centralized control. That is called a peer-to-peer. Guys, understand what is peer-to-peer?
Yes, sir.
Very good. So here it is, centralized one. So for example, I have a server. Think like it is a web server or a file server, a DHCP server or DNS server, Active Directory domain controller server, and I have a client PCs. For example, it is a web server, okay, and you access web page from the web server. Okay, for example, you access a web page from the web server. Yeah, there are a lot of things are open. So I will go to Java T point again. It is a web page is appear when I open a URL with a server name. The request go to the Java T point web server and gives the page on my screen. Okay. So I'm a client. So I'm a client. I send a request to my server for certain service purpose. For example, if it is a web server, I will send HTTP request. Okay. So web server understand what you want. You want a web page because of the protocol. Okay, you send request to the web server. I want a web page. How you will access? HTTP :/ web server address. Then web server understand what is your requirement. It is a web service and it will send web page to you. So in your browser, you can able to see your kind of stuff. See it is, what is this? HTTPS :/ www.javatpoint.com. What is www.javatpoint.com? It is a web server name of javatpoint.com. That is a web server name. What is HTTPS? Is a protocol which is you are requesting, I want a web page. And what is this? Where are you doing it? From the web browser. What is a web browser? Is a application to access website. Web browser is an application to access websites. Different kind of websites, of course. Over website kind of stuff, right? So here it is. What I have done, I send a request to the server. Server send a response to the client. Simply say server and client. Guys, server provide a service. Client access that service. Okay. But server never directly give service to the client. Server never give a service to the client. Okay. Client has to request first. You want a web page, you send a request. You want to send a mail, you have to send a request to the mail server. I want to send a mail. You want to receive a mail, you have to send a request to the mail server. I want to retrieve my mails. You want to upload a file, you want to send a FTP request to the file server. I want to upload a file. Okay, you want to download a file, you send a FTP request to the server. I want to download a specific file. This, guys, the client requests to the server what service it required. server receive the request and understand who is asking, what is asking, and if it is available, it respond to the client. As I said last class, 404 error. What is 404 error? You open a page, for example, you open a page and the page is not available at server side, or maybe you are given wrong page name, then you will get a 404. So you send a request, I want this page. You send a request to the web server, I want this particular page, and it is verifies the page is available or not. The page is not there, then it will throw a response called a 404. Page is available. It will give page is available. It give the page display as a response. Response is, yeah, I have a page and take this page. You can view the page. If page is not available, it send 404 response. Okay. That's why it is always written client send for a service. Client request for a service to the server, and server send response to the client. Is it a service is available, not available, space is available, or connectivity is available, database is available, like that. Okay. So I given same example, I written same example, web server example. Web server has a web pages, you can access through web services. The client, which is from web browser, you can access web pages from the web server. Okay. So client has to request to the server, server responds to the client. So it is a server and client model. Of course, there are a lot of things that happens in between, but for simple idea, it is. How server understand what is your request? I send a request here, Java T point request. I want a web page. How can I say? Based on the HTTP. For example, I send a request here, ping www.javatpoint.com. So I'm getting a ping replies, not a web page. Why? Because of the ping command use ICMP protocol. ICMP protocol means connectivity testing purpose. Ping is for connectivities, there are not for web page, right? So like that. So FTP protocol, or you use SMTP protocol. If the service related protocol is there, it will respond according to you. The service availability is not there, so then it discard it. You don't worry about it. Okay. So that is the server understand the client request by the protocol. Is it HTTP request or HTTPS request, FTP request, NTP request, ICMP request, okay, or a TFTP request, FTP request, SNMT request, SNMP request, POP3 request. What request they are doing, what kind of service they are asking from me. They will understand, the server understand by the protocol. Guys, understand these 4 points. Server and client. What is server? What is client?
Yes, sir.
Okay. Next. Yeah, okay. I said web server, one server. And there is a DHCP server, DNS server, WDS server, WSUS server, remote desktop server, virtualization server, VPN server, FTP server, TFTP server, mail server. So we are making like a lot of list of servers, right? Server. How a server, a system becomes a particular server. A system, how a system or a server becomes a particular server. How a computer or a system or a server become a particular type of server. You said this is a server. But what server it is? DHCP server. How it is become a DHCP server? How can it is provide DHCP services? We said this is a web server. How it is become web server? Okay. So here it is, guys. When you take a system or a server OS, you can install a specific application or you can enable or install the built-in features or roles inside the server. For example, you take Windows Server operating system, simply select DHCP server. And next, install the DHCP server role in the Windows Server and configure. So it is become DHCP server. You want to make a Linux machine as a web server. Okay, as a web server. Install Apache HTTPD in the Linux machine, then configure it. So how it should be connected and can access. So yeah, once you install and configure that HTTPD package, then it is become web server. Some of you know NGINX. NGINX. It is also an application. Once you install this application inside your Linux machine, and it is become a web server. Tomcat. You install a Tomcat in a machine, it become web server and application server also. So how a server become a specific particular type of server, particular type of service it is providing. How it can be do? By installing and configuring the built-in features or roles, or by installing applications or packages inside your system, means inside your server system. So it is become a particular server. We can call them as it's a web server, it is a DHCP server, it is a deployment server, it is a ticketing server, like that. You can say by installing that related application or enabling or application or a package, or by install and configure built-in roles and features. Okay. So we'll go to the next. Servers. You calling something as a server based on its service it is providing. So based on what service it is providing, what are the different types of servers? Here it is: web server, file server, DHCP server, DNS server, domain controller, domain controller, domain controller, WDS server, deployment server, mail server, VPN server, database server, storage server, virtualization server, like that. Lot of servers are there. So if you take a web server responds to the web related protocols, HTTP, HTTPS. Okay. How a system become a web server? By installing or installing and configuration of built-in roles or features, or by installing applications and configuration of applications, packages, kind of stuff. MS Microsoft Windows Server has a IIS, Internet Information Service. So once you configure in the Windows servers, it is become web server. If you install my Apache HTTPD also, and it is become web server. Install like Tomcat, Glassfish, NGINX. Okay, these applications are packages installed on a machine, so it is become web server and application server. File server, the protocol is FTP, file transfer protocol. Use BSFTP, SFTP kind of stuff by enabling for a security purpose. What is a file server? You can upload and download a files. So usually it is a built-in either it is a built-in inside your server, or maybe you can use FTP installation in it. Okay. Mostly I've seen it is integrated in a Microsoft Internet Information Service. DHCP. DHCP server. It is simple. A DHCP protocol will be the access protocol. Here it is port number 6768. And how it is? By if it is a Windows server, just you have to go to the roles, install the DHCP role, and it is become DHCP server. Of course, you have to configure it. If it is a Linux-based systems, then you have to install DHCP related package and configure it as a DHCP server. DNS server, domain name server. Domain name system is a protocol. What is it to? It resolve name to IP addresses. Port number is 53. By simple, by enabling its roles in Windows Server, then it is become DNS server. Windows deployment server. You can install operating systems in multiple systems. Okay. WSUS, Windows Update Service related. You can update your local machines through this WSUS server. And you can control the updates also. Authentication server or a domain controller. By installing or configuring AD or ADDS, okay, then it is become authentication server. It controls and authenticate users when they log into the domain. Protocol, understandable protocol is Kerberos. Mail servers. Mail server. SMTP, POP3, IMAP. These are the three main protocols to communicating with the mail server. So by installing Microsoft Exchange application in the Microsoft servers, then it is become mail server. Or you can install Zimbra or Squirrel Mail, Tomcat. Applications are a packages in the Linux and configure it, it become mail server. Guys, so like that. So it's a VPN server. Storage servers are there. Database servers. You download a Oracle DB application and install into the server and configure and give them access. Then it is become a database server. Virtualization servers, it is a I written bare metal type means no additional OS requirement is not required. It can be directly installed in your core machine, core server it is. So then it is become virtualization server. So you can create a multiple virtual machines in the virtualization server through access. Server OSs. Yeah, understand guys, different types of servers and what type of service they are providing and what protocols, what application helps them to make a particular server as a specific type of server.
Yes, sir. Good.
Got it? Okay. So here it is, servers, Windows servers, Linux server operating system, Unix server operating system, Z by OS or AS by 400. Okay, these are the different OS kind of stuff. Okay, so from Windows having a desktop and as well as a server operating system separately. So I've written some of the main Windows Server operating system and their version. See, Windows Server NT 2000, 2003, 2008, 2008 R2, 2012, 12 R2, and 2016, 2019, 2025. Maybe in future 2025 will also come. Okay. In a Linux also we have a different Linux distributions as a server distributions. Red Hat Enterprise Linux, CentOS, Fedora, Debian, Ubuntu servers, like that it is also there. Unix is HP Unix, Solaris, and stuff. Microsoft Hyper-V server, VMware vSphere, Xen server, Proxmox E. These are a direct OS kernel type kind of stuff. Means it contains majorly kernel part or less in a user access purpose, shell part. By installing these things like an operating system into a server, it is become virtualization server. Guys, understand what are the different server operating system? Currently, Windows 2019 and 2022. Yes. Linux is Enterprise Linux 9 version. Linux is Enterprise Linux 9 version. Anything you can take, Red Hat Enterprise Linux, Oracle Enterprise Linux, or CentOS. So that is version 9. Okay, good. So we came from bottom to top, okay, top to bottom, or whatever it is you think. The first thing is I discuss different types of servers. But to build these different types of servers, like it can be web server, DHCP server, DNS server, or any server it want to make it. So sorry, we need to install a package or by install a role or a feature and configure it as per a specific server. So then we discuss it has to be installed. That means it need some operating system. And again, what operating system it is? Either it can be Windows Server operating system, Linux Server operating system, or Unix Server operating system. Okay. But these OS also run on the machine, right? Normally, our laptops and desktop not mentioned for a 24 by 7 running. Okay, it's not thing is like you can able to run. You cannot because your normal hardware is different, capacity is different, physical capacity, running capacity is different from the server hardware kind of stuff. Okay, so there they use this type of processor like Exxon processors, 16 GB RAM, 32 GB RAM, 64 GB RAM, like that. So these servers use. Yeah, I'm getting thirsty or a headache or I don't know. Okay. So in the organizations, we use mainly three types of servers. One is tower server. The tower server is look like a big desktop system. Okay. So if it is shows bigger picture, that is a good thing. Not showing any pictures are there. Okay. Okay, so this is two SMPSs for main power supply connection, back panel connectors. This is the front side hard disk, SAS hard disk we can directly insert. Maximum RAM support is 1 terabyte. Maximum storage capacity is 360 terabyte. Xenon processor is given. Okay, number of processors we can put two. Okay, drive types and other dimensions also given. So this is high towers. So it is cost is now can you see this cost is around 2,78,000. Guys, for example, my organization is very small organization. I need a three or four servers. One server for a active directory purpose, another for a storage purpose, another is for some other application running purpose, or connecting, remote connecting purpose, or a dummy terminal like that. So for my organization, I require 4 servers, or I can accommodate the place for the server keeping, connectivities, monitoring devices, system connectivity, we can able to make it. So for that purpose, the suitable is tower server. Next one is blade server. So why we should go to the blade server? So in case, first of all, I will show you what is blade server. Not blade, rack server, sorry. Blade is also there. So then you will see. This is one rack. It's a simple one rack. Okay. So rack is also a server. One rack, one server it is. One rack, one server. It contains a processor, it contains a RAM, it contains storage, it contains this SAS type of storage. SCSI storage is also given. You can see this, the infrastructure details. Xenon processor, 12 core processor, 32 GB DDR4, 1.2 GB RPM SAS disk storage is also available. Okay. Depends on the model, different capacities. So what is the rack mount? One rack, one server. It contains just like your tower server. It is has a storage space, SCSI type of storage space as this. Second one is CPUs. Number of CPUs are there, processors, RAMs, and everything is available. Okay. So when you compare with rack server to data tower servers, rack servers occupy lesser the space, and these rack servers can be fit in a simple rack. Okay, that's it. They will build this rack servers. And the connectivity of cabling connectivities and all other connectivities will be lesser. Normal tower server, the wiring, place occupation, okay. So the distance between one server to another server is higher. It also feel difficult. But these rack servers, as an advantage, it reduces the spaces. No need to put at different places. You can directly put. Okay, sorry guys, I'm just having neck pain. Wait, wait. Okay, so this is rack server. What is the blade server? In rack, they'll put a multiple blades inside. So I'll go to the images there. I can show both the rack and blade server. This is a tower server, and if you see this guy is inserting a blade. This is the blade. This is completely one single rack. In this rack, we have a multiple blades. Okay, that is multiple blades are there. Each blade is one single server. If you are compare tower and rack server, the blade is very single blade is cost is very less. Why it is very less? Because In the towers and rack servers, we have separate storages. It is a connected internally. There is a separate storages are there. Means multiple hard disk spaces are there. Multiple processor capacities also there. Okay, it's a one server, one blade, one blade, one server, one rack, one server, one tower is one server. Okay, but in this one, in a blade servers, we do not have more storage capacity. The storage has to be stored in a centralized storage only, not in internal storage. Internally, only operating system applications and the basic support required storages only, not it. But blade servers save lot of space. You have to run, you need more computing power and the storage power is separated. Then we choose blade. Less space occupation, lesser the cost, and more high availability. We can easily achieve because high availability means is a even one server is down, you can run with another server. So like that, we can easily configure high availabilities with the blade servers. Okay. So these are the main three models of servers: tower server, rack server, blade servers. Okay. In this pattern, I am telling in the hardware capacity wise and the different models. Okay. Hardware capacity also like it separate processor. We don't use processor daily like that. We use i3 processor, i7 processor, AMD processors only, but we don't use Ganon processor for your desktop. But here we use Xenon processor. It's a multi-core processor. Higher RAM capacity possibility is there. Higher storage capacity possibility is also there with these touch servers. Okay. The tower, rack, and blade are different form factors of these hardware servers. Tower is just like a your desktop model. It is tower model, high tower model it is. It is contains the processors, RAMs, storage also inside. Both in storage, normal SCSI storage, SSD storage, a RAID controllers also there inside. Okay. And rack server is also same, but thing is rack server it will be fit in a rack only. Tower server you can place any place. Simply one stand is enough. Blade servers are smaller the size and multiple blades you can insert in one big rack. It is like a 16 slot rack is there, 8 slot rack is there, 4 slot rack is there. We can just simply insert these blades into the rack. It's hot swappable. If any blade is failed, we can remove it and reinsert a new one and auto configure in the high availabilities. Okay, guys, up to here.
Yes, sir.
Yes, sir.
So finally, data center. What is this data center? We discussed about a different type of servers. So in the servers, we run a multiple type of different type of applications. Mail related applications, mail server related applications, right? Web server applications, database applications, okay, and runs in a different type of server. So then it will provide a different type of services. And where we run in the different operating systems, where it is located inside the physical servers, where the physical servers are located in the single room, that we call it as a data center. What is a data center? It is contains okay servers. It can be like rack server, blade servers. Servers are there on top of server and they are connected. Server has to be connect from communicate between one server to another server to outside, connect network, inside network. So network components are required, like routers, switches are required. Applications are running inside. Okay, for connecting, say keep application software side. I'm physically imagine physically. we need a servers. Either it can be rack server or a blade servers. We need to connect the servers. So then we need a networking components, routers, switches, fiber optical cables, UTP cables. Okay. NICs, regular Ethernet NICs, HBS, host bus adapters for fiber optical connectivities, firewall devices are required, right? Servers, networks, storages, different type of storage components are required, like a not regular disk, like a SCSI disk, SAS disk, different type of storage plans. So centralized storage is required, like a SAN and NAS storage types are required. Okay. Uh, Access like a RAID, redundancy purpose, RAID, LVM, we should configure it. And finally, we run applications. Plus, that is a physical infrastructure. And you have to provide power supply, main power supply, backup power supply, generators also required. Okay, main power supply is down. You need a backup power supply. UPS is required. So then servers runs continuously. Server has to run 24 by 7 compulsory. Okay. So when power is off, main power is gone, then server is down, and you say no, no, no problem, we cannot provide. Not like that. So you have to provide UPS. But UPS work for 1 or 2 hours only. Then what to do? Then you require generators. Any sudden power surges happen, so your power is your servers will be down. So to prevent it, we are using UPS. Once UPS is on, meanwhile start the generators. You are using generator means generator require diesel. You have to plan for a diesel storage also. Okay, you want to start a generator and you don't have a diesel, then you have to go to petrol bunk and fetch the diesel by 5 liters can and pouring it. No, no, no. It is. So you have to store the diesel. Okay, so that is power supply. Power supply, main power supply, backup power supply also you should provide it. And the servers are produce lot of heat inside the server room, right? So what you have to do, you have to follow the cooling system. Provide a proper ventilation, means dry ventilation, not a one-way ventilation. Heat has to be go outside, not nothing should come inside. Okay, cooling systems like AC supply kind of stuff is required. Temperature you have to maintain constant temperature. Oxygen supplies, nitrogen supplies, carbon dioxide supplies, all these things has to be maintained properly. Because if you are more oxygen, a small spark also give big fire, right? Small spark become big fire, more oxygen. Less oxygen, people who are working, they will die. People working in the data center, they will die if no less oxygen. Okay, so you have to balance the mixture. See, this is a small data center, very small data center it is. See, it is, if you are looking at, I can up, you can see. So there is, this look like, here it is, PoE switch for IP phone. IP phone, like if you have a connecting, like IP telephone, voice or IP kind of stuff, that is a switch for that one. And SAN, NAS storage is there. iSCSI RAID 6 configured iSCSI SAN is there. So the storage related 10 terabyte. 4.7 terabyte fiber channel SAN is there. SAN storage, centralized storage. And there is a vCenter server, that is a VMware vCenter. So it will manage a multiple VMware ESXi servers. You can see vCenter server 6.0 beta 3. It's a very old one. Okay. Then there is a how many servers? Two Xenon processor, 24 logical core, 32 GB ECC. Okay. And a data store on a iSCSI SAN. So that is ESXi machines are created in that server, in a one rack server. OpenStack servers also there. Okay. Open VMS, fiber channel, SAN switches are given here. So it is in the data center. It is 2014, means 10 years back data centers. Okay, that's what it is showing the older versions. Okay, in these data centers, it is like what we can say, it has a virtualization servers, storage servers, blade rack servers are there, storage servers are there. Okay, blades are there, racks are there, fiber optical switches, fiber optical SAN switches, fiber optical connecting fiber optical lines. Okay, SAN storages, NAS storages also there. Okay, that's why it is. I said, what is a data center? Data center means it is. This is simply is a combination. It is the data center means it contains servers, networking devices. Server means it can be a blade or a rack servers, networking devices like router switches, fiber optical switches, okay, firewalls, cables, fiber optical cables or UTP cables, storages like a SCSI SAS type of disk we use it, okay. It's different storage types, centralized storage types are SAN and NAS type of storages, redundancy, RAID and LVM configured storages also. Different applications are running in this server, which is different purpose it will provide. Okay, I showed the diagram that is mainly virtualization purpose, VMware virtualization purpose only. Okay. So yeah, there is a one more point. It is a data center monitoring. What is meant by data center monitoring? You have to monitor your infrastructure. How many servers are there? How many servers are working? How much? What is the network connectivity? Is any network outage is happen when any segment of network is get problem? Okay, so you have to monitor your servers, server running applications, their performance, server statuses, network connectivities, network status, packet traveling, write controllers. Okay, so disk management like a disk monitoring, write controllers like a is any write is failed after configuration, the write is working or failed. So what to do immediately? Any disk is failed, how to react? Everything we can able to monitor. You can monitor your servers, applications, network, storages. Everything we monitor from centrally. Just in case your profile is you by accidentally you choose, you got a profile that is once you join into the organization. If you got the data center monitoring, do not say no. Better to learn. Okay, because the monitoring is a real job. Okay, because as a freshers to the experienced people, the critical points is monitoring. Okay, guys, this is a main introduction about your servers and services. What is meant by server? Different types of servers. Okay, I explained it. Okay. The next one I will going to explain about a few things is like this about your individual computer. So the user account authentication kind of stuff. Another one is also there, that is. Then I will discuss about a work group and then domain and work group and domain differences. Okay, what is a domain? What is a domain controller? Okay, how to check are you in the domain? Are you in the work group? Okay, what is active directory? Like that we will discuss. Take a small break, guys.